Good morning, dear friends. In the last session, we have seen how we can derive the Kirchhoff voltage law, and when the polarity of the voltage and current are changed, how the matrix will be changed. Everything we have learned. Today, we are going to do the problem related to the Kirchhoff voltage law, where we can see the two loops, and it consisting of the current is I1 and I2 in the two loops. Resistance are 5 ohm, 10 ohm. In between these two resistance, we have, in between the two loops, we have the 6 ohm resistance and the 8 ohm resistance here. Now, we are going to directly write the Kramer's matrix from this. So, we know the voltage matrix is equal to resistance matrix into the current matrix, right? Resistance matrix into the current matrix. In the voltage matrix is 2 cross 1 matrix. Similarly, I is also 2 cross 1 matrix. This R is 2 cross 2 matrix. Okay. So now, if you see this the 2 cross 2 matrix, we have to write R11, R12, R21, R22. So now I am going to write this voltage. We have two voltage source. This is we can consider as V1. V1, but in this case we have only one source, and since the second loop there is no voltage source at all. So what we have to do, the second source V2 is nothing is there, so we have to be considered 0. So we can write it now. V1 is 100 and V2 is 0. There is no voltage source, is equal to R resistance matrix. R11 is nothing but sum of the resistance in the one loop. So that 5 plus 6, 5 plus 6. Then R12 is nothing but common resistance between the two loops. Common resistance between the two loops. Therefore, here 6 ohm is the common resistance. However, current I1 is going down and current I2 is going up. I1 and this is I2. Therefore, we have to write minus 6. Then similarly, R21 also minus 6. Then the second loop. What are the total resistance in the second loop? That means 6 plus 10 plus 8 into the current is I1 and I2. Okay, I1 and I2. So when we simplify this equation, we can write 100, 0 is equal to 11 minus 6 and 24 I1 and I2. I1 and I2. So now delta is nothing but determinant of 11 minus 6, 24. We have to do the cross multiplication of these two. That means 11 into 24 minus 6 into minus 6. So we can write now the final value of delta is 228. Final value of delta is 228. Then delta 1 is nothing but first column we have to replace by this voltage matrix. Therefore 100, 0. Then second column as such, that means minus 6, 24. So we can, if you multiply it, we will get minus 6 into 0, 0. Therefore 2400. Similarly, delta 2, we can write here delta 2 is nothing but first column as such 11 minus 6. Second column we have to replace by this voltage matrix 100 and 0. So we will get the finally 11 into 0, 0. Therefore, delta 2 is equal to 0 minus of minus 6 into 100. That is equal to 600. Okay. So from this, we have to be find out what is the value of I1. I1 is nothing but delta 1 by delta. I2 is nothing but delta 2 by delta. So I1 is equal to delta 1 already we know 2400 divided by delta is 228. I2 is delta 2 divided by delta. Delta is nothing but 600 divided by delta is 228. Let me check the final value as I1 is 10.5 amps and I2 is nothing but 2.63 amps. Okay, 2.63 amps. So now I am going to measure what is the voltage. I am going to verify the Kirchhoff voltage law also with this. So now here in this 5 ohm resistance only I1 current is flowing. In this case, in this 6 ohm resistance, I1 minus I2 is flowing and 10 ohm I2 current is flowing and 8 ohm also I2 current. So from this, I am going to calculate all the values. Voltage across 5 ohm resistance is nothing but 5 ohms, Ohm's law, I into R. Resistance current which is flowing through the 5 ohm resistance is I1, that is equal to 10.5 into the resistance is nothing but 5 ohm. So that is will be 5. Then so 100 for 10.5 into 5 we will get 52.5 volt. Then voltage across 6 ohm resistance, voltage across 6 ohm resistance, I1 minus I2 into 6. So therefore I1 minus I2 into 6 ohm, that is equal to I1 will know 10.5 minus 2.63 into 6. So I2, so this voltage across this 6 ohm resistance is 47.22 volt. Then we have to measure voltage across the 10 ohm. The voltage across the 10 ohm is current which is flowing through the 10 ohm is I2. So therefore I2 into 10, that is I2 we already know 2.63 into 10, that is equal to 26.3 volt. Then finally voltage across the resistance 8 ohm, I2 into 8 ohm resistance, I2 we already know 2.63 into 8, the 2.63 into 8 is the final value will be 21.04 volt. Let me draw the circuit again. Here resistance, here also resistance, this is one resistance, we have another one resistance, this is the voltage source. So if we have, this is 5 ohm and this is 6 ohm and this is 10 ohm and this is the 8 ohm. Already we know voltage across the 5 ohm resistance is, this voltage is 100 volt. Therefore voltage across 5 ohm resistance is 52.5 volt. Voltage across 6 ohm is 47.2 volt. 47.2 volt. Then we have the voltage across 10 ohm is 26.3 volt and then voltage across 8 ohm is 21.04 volt. So if we add 52 and 47, 52.5, we will get approximately 100 volt. That means this 100 volt is divided between these two, 47. Then this is the parallel connection and these two are connected in series. So the 47 volt divided into 26.3 plus 21. That means we can write 100 volt is equal to voltage across the resistance 5 ohm plus voltage across resistance 6 ohm. Then this voltage across 6 ohm, that is equal to 47.2 is equal to voltage across 10 ohm plus voltage across 8 ohm. That means 26.3 plus 21.04, we will get approximately 47.2 volt. So hence this Kirchhoff voltage law is proved. I hope you understood how you can verify the calculated value and the final values are correct or not. Wish you all the best. Thank you.